Math 230, Cuesta College. I'm Joe Vasta, and this lecture is on 6.2, counting words. So what are we going to do in this one? Well, before we do this one, let's show you the puzzle. Which word comes next? So you have a list of words, gun, shoe, etc. And so I didn't have room to put a little box here, but what comes after gate? And there's more than one possible answer. We'll take a look at this at the end of this lecture. Consider 4-letter words to be formed by using the letters A, B, C, D, E, F, G, H, I, J. Okay. So what are we talking about 4-letter words? Well, you might have been able to create some 4-letter words, like maybe bead, or deed. This one actually repeats letters, and this one here does not repeat letters, and that's going to be actually important. So, hide, and the list does go on, dead, etc. But we could also consider, see, words as in quotes. So this is kind of like if you were coming up with a password just with these. So you could actually have A, B, C, D. That's considered a word in quotes. Okay. So here's one of my favorites here. Ah! Okay, so there's a word for A's, etc. So you can go F, G, J, D. There's a word as well. So the list goes on, and there are many words. So what we're going to be doing is we're going to be counting these 4-letter words in the next 10 problems. So we'll cover 10 problems, counting words. It's going to be a little bit more complicated than the last section, which was 6.1. How many different words can be formed if repetitions are allowed? So we're allowing for ah and deed. So we're allowing for all this stuff. So what we're going to do is when we create a 4-letter word, we are actually making 4 decisions. So there are 4 slots. Really, we don't really need the slots when we do this, but you know, after problem 2, we will be happy that we have the slots. So how many choices do we have for the first letter? Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 letters there. Repetitions are allowed. So how many choices do we have for this? Well, 10. And for this one, 10. And for the last slot, 10 as well. So I'm going to go 10 times 10 times 10 times 10. Now the quick way of saying that is 10 to the 4th. But it's really going to be a 1 followed by 4 zeros. So how many different words can be formed if repetitions are allowed? 10,000. So this is what I meant maybe in the last video, where chapter 6 is learning how to count. When you first hear that, you're like, well, we all know how to count. But this is actually counting without counting. So we got 10,000, but we never really counted all the way up to 10,000. We multiplied numbers together and got our answer of 10,000. Okay, so now this gets a little bit more tricky on problem 2. How many different words can be formed if repetitions are not allowed? So let's put 4 slots. And I'm going to put the letters right here. A, B. I'm going to use a green pen. What I write in green is not part of the answer, but it's going to help me get the answer. So what I'm going to do is we're going to go here. We're going to say, how many choices do I have for the first slot? Well, there's 10 choices. We can count them again if you want, but I'm going to go ahead and put a 10 there. Now, repetitions are not allowed. So what I'm going to do when that happens is I'm going to go ahead and select one of these letters. I'll select a G. I'm going to put it right there. Now, because repetitions are not allowed, I cannot use the G again, so I'm going to cross it out. Like I said, the green is not part of the answer, but it helps me get the numbers below. So how many choices do I have for the second slot? Having a G there, well, you can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I have to decide to put a letter there. Let's just put a D there. Now, so if you're thinking to yourself, well, why did you pick the D? You can pick whatever letter you want. In the end, you'll still get the same numbers underneath the slots. Okay, so I put a D there. And I say, how many choices do I have for this third slot where we've already used up 2 letters? And you can count them. There are 8 letters there. And so let's go ahead and put maybe an I there. So now my last slot, how many choices do I have for the last slot? Well, 1, 2, 3, 4, 5, 6, 7. And so it's optional, but we can put a letter there, H, whatever. But that's not important. The green part is not part of the answer. The answer is going to be 10 times 9 times 8 times 7. I'm going to do things in these lectures without a calculator. So what I'm going to do is I'm just going to multiply these together. I'm going to go 9 times 8 is 72 times 7, 14, carry the 1, 49, 50, so 504. So 9 times 8 times 7 is 504. And we're going to multiply it by 10, so we just add a 0 to that. So when we multiply this, we end up getting 5040, which is 5040. And I said this in an earlier video, but it's my preference, this is just a matter of style, not to put a comma when the number is 4-digit, but when it's 5-digit or higher, then I use commas for the placeholders. So that is how you do these problems. Are the problems going to get a little bit more complicated? Yes. But just follow these lectures. You can pause them and think about what I say and what I do, which is an advantage of doing face-to-face. Now, face-to-face, the advantage is the interaction, the questions you can ask as I do these problems. Let's go ahead and look at problem number 3 and 4. Normally I would say, hey, why don't you pause the video and do these? Some of you may be able to, but there's some new things that we're going to see in these problems. Remember, these are 4-letter words using these letters, and I went ahead and repeated them here for each of the problems. How many different words? Okay, so what I'm going to do is I'm going to go ahead and put the 4 slots. How many different words whose last letter is D can be formed if repetitions are not allowed? So we're going to get to that. I guess I should say a few more things about this. Okay, this is kind of poor planning. Notice when repetitions were not allowed, the answer was less than when repetitions are allowed. Okay, there's 10,000, and over here we had a little over 5,000. Why? Because repetitions are not allowed, so we're restricted on that. We don't have as many choices. Like when reps are not allowed, we cannot have ah, and we can't have deed, and we can't have anything where there's repeating letters, and that's why there's less. So I should have mentioned that. Let's get to the other one. How many different words whose last letter is D can be formed? Repetitions are not allowed. Well, what does it say? It says the last letter has to be a D. You have to have a D right here. So when they tell you you have to have a certain letter on one of the slots, I'm going to make that slot be red. And I'm going to call that last letter is D a restriction. Now, with a restriction, I always label those first, because if I don't, I'll probably get the wrong answer. So the question is, how many choices do I have for that last slot? Well, I only have one choice. I have to put a D there. Now look at this. Repetitions are not allowed, so I have to cross off the D. Always do your restrictions first, or you're going to get burnt. Okay, now we go to the first slot and say, well, how many choices do I have for that first slot? Well, you can count them up. Do not count the D. You actually have 9. So now we're going to put a letter on that first slot. So maybe I'll put a B there. Okay, now having done the last slot and the first slot, how many choices do I have for this second slot? And you can count them. 1, 2, 3, 4, 5, 6, 7, 8. So pick a letter. You know, it doesn't matter which letter you pick. I'm gonna pick an E. Okay, so there's an E there. And then how many choices do I have for this third slot? Well, now if you count them, you'll see there's only 7 letters I can select from. So I'll put an A. So bead is one of the words. And so let's multiply this. 9 times 8 times 7 times 1. Now we did 9 times 8 times 7 in problem 2. We saw that that was 504. And that's our answer. So let's go ahead and do problem number 4. How many different words whose last letter is D? So it looks like the same problem. But look at this. It can be formed if repetitions are allowed. So reps are allowed. 4-letter words. There is the restriction right here. And so I'm going to do my restriction first. I need to have what there? I need to have a D there. So there's one way of doing that. Now, having put a D there, how many choices do I have for this first slot? Now remember, repetitions are allowed, so I'm not crossing anything off. So there's actually 10. So I'm not, you know, when reps are allowed, usually I don't go ahead and write up the whole, you know, one example. I'll just go ahead and leave them blank because I know that there are 10 choices there and there are 10 choices there. Why? Because repetitions are allowed. So the word could be D, 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 D if I want. Just the last one has to be a D. I'm going to multiply that together. 10 times 10 times 10 times 1. Okay, it's going to be a 1 followed by 3 zeros, which is 1,000. And so there we have it. Now we know about restrictions. We also see that when we have a restriction, look at this. Look at the answers. You know, I know it's kind of crisscrossed. Where repetitions are not allowed, it's 10,000, but when we have a restriction where the D has to be the last letter, it is just 1,000. And then the same thing, when repetitions are not allowed, it's like over 5,000, and then when repetitions are not allowed, but the last letter has to be D, then it's less. Let's go ahead and take a look at some more problems. So problems 5 and 6. Now might be a good time to see if you can do the next two problems on your own. And notice they almost look the same, except on the first one repetitions are allowed, and this second one, which is problem 6, repetitions are not allowed. So, you know, might be worthwhile pausing the video to see if you can do this. Okay, problem number 5, repetitions are allowed. I'm going to put 4 slots. This one's a little short. There we go. And what does it say? How many different words whose first letter is not a vowel can be formed if repetitions are allowed? So your restriction is right here. It says first letter is not a vowel. There's your restriction. So if it's not a vowel, it's a consonant. And so how many, we'll just call them non-vowels, do you have? Well, you have the B, the C, the D, so we don't want to count A, E, or I, F, G, H, J. So if you counted those, I think that was 7. 1, 2, 3, 4, 5, 6, 7. So I have 7 choices that I can pick from. Okay, if the first letter is not a vowel. Now, because repetitions are allowed, I'm not going to go ahead and write the things in green above. So whatever I put there, I mean, if I put like a B there, I could put a B on the next slot. So how many choices do I have for the second slot? Well, 10. And for the third slot would be 10. And for the fourth slot would be 10. So I multiply these numbers together. 10 times 10 times 10 is 1,000. 1,000 times 7 is 7,000. There it is. So usually people find repetitions are allowed to be a little easier than the next one where it says repetitions are not allowed. Okay, so problem number 6. Our restriction is first letter is not a vowel. We have 4 slots. There's your restriction. And so, let's go ahead and put a non-vowel on the first one. Well, first of all, how many choices do I have for that restriction? 7. I must do my restrictions first. And so I pick a letter like J. That's a non-vowel. And because repetitions are not allowed, now I'm playing this game with the green pen where I cross that out. So now how many choices do I have for the second slot? I have 9 choices. You can count them. And so maybe I'll put an A there. And so when I do, I have to cross it off. Now some of you might be able to catch on and not have to put the green stuff in, you know, after a little while, but for now I'll put them in there, okay, these letters above. How many choices do I have for the third slot? I have 8 choices. Okay, so let's go ahead and put an H there. And how many choices do I have for this last spot? Well, 1, 2, 3, 4, 5, 6, 7. So, you know, I'll go ahead and put a C there. Whoops, and it should be in green. And so that's what I have. 7 times 9 times 8 times 7. So 9 times 8 times 7, we saw from problem 2, was 504. And then I'm going to multiply it by this 7 here. So 28. The 2 goes up. You carry the 2, but then 7 times 0 plus 2, so this is 28. And then 7 times 5 is 35. So the answer is 3,528 different 4-letter words whose first letter is not a vowel, where repetitions are not allowed. So that is the deal with this. I hate doing this, but I'm going to do it anyway. I'm going to come back to here, to these problems. I want to remind you that you should always do your restrictions first. So if you didn't do your restriction first on this one here, I know this is problem 3 and it's been a while since we did it, and you went ahead and you said 10, 9, 8, and then a 1. Well, when you put a 10 there, you're saying that you can have a D in that first slot. So you would actually be overcounting. So always do your restrictions first. And that's going to make a difference when repetitions are not allowed. Now, when repetitions are allowed, it doesn't matter if you do your restriction first, but I'm going to say, just to avoid confusion, just always do your restrictions first, because you'll always get the right answer. Now, in the problem that we did, our restriction was where? In the first slot. So I always do my restrictions first, because that will burn me when repetitions are not allowed if I decide to go willy-nilly in terms of the order. Okay, so problem number 7. Let's see if we can find it here. Here it is. How many different words whose letters at the ends are A and B can be formed if repetitions are allowed? So there's a restriction. It says whose letters at the ends are A and B. And notice, this says and. Okay, so the letters at the ends, when we say at the ends, we mean, you know, like if I have a word that looks like this, like A, C, F, B. This is the ends. This is the front end, this is the back end. So the letters at the end of this word happen to be A and B. And so I can't have the word A, because it says the letters at the ends are A and B. So you could allow for this, like you could have B, A, C, but then the last one would have to be A, because the letters at the ends have to be A and B. Okay, so that is the nature of this problem here. This says repetitions are allowed, so this one is allowed. And let's go ahead and put our 4 slots. Your restrictions are where? There and there. Okay, so I'll start off with this restriction. Doesn't matter, as long as I do my restrictions first. How many choices do I have for this first slot? I have 2 choices. And I'm actually going to write out a word maybe. So I can put an A there or a B there, as you can see. I'm going to go ahead and put a B there. Now I go to my other restriction. How many choices do I have for that one, knowing that there's a B there? Well, it says the letters at the ends are A and B, so you would have to put an A there. And that means there's only one choice. Now, had I put an A there, then there would still be one choice. I would have to put a B there. So a 2 goes there, a 1 goes there. Now, repetitions are allowed. So now on this slot, I can put any of the 10 choices. So, I could put a C there. And then here, I can put any of the 10 choices. So I could put like a J there. And so my final answer is 2 times 10 times 10 times 1, which gives me 200. Now there is another way of doing this problem if you did not like that way. So there's a Roman numeral 1. Here's Roman numeral 2. You could do this problem the following. You could say, when I'm looking for words that fit this description, I can have an A there and a B there, or I can count the words, so I can have a B here and an A there. Now I'm showing you these two ways because some people might like the second way better. Now once I have an A there and a B there, those are restricted then. And then over here, that's restricted as well. So think of it this way. I'm going to count all the words that look like this, and then I'm going to count all the words that look like that. And then the OR actually means I'm going to add those two together. So if I have to put an A there, there's only one choice there, and if I have to put a B there, there's only one choice right there. Now because this is repetitions are allowed, under those slots I'll put 10s. And multiply them together, and guess what this gives me? This first part gives me 100. Well, in the same or a similar fashion, we can do the same thing here. There's one choice for this red slot and one choice for this red slot. And then because repetitions are allowed, we can put 10s there. 1 times 10 times 10 times 1 is 100. 100 plus 100 is 200, which is really what we got. Now some people like it this way because you just did it all in one thing. Now, some people like it this way because they like seeing it broke up into two different things and breaking the problem down like that. So that is problem number 7. Problem number 8 is going to be similar. See, look at this. You've got the same restriction whose letters at the ends are A and B. And we'll note that this is an AND. So we got to have A on one end and B on the other end. But this problem says repetitions are not allowed. Repetitions are not allowed. We know the answer is going to be less than 200. Maybe you want to pause the video and see if you can do this one on your own. Okay, let's go ahead. I'm going to do it that first method that I showed you. I have 4 slots. My restrictions are right here and right here. I must do my restrictions first. If you want to start it off, if you were going to start right here and say, okay, I have 10 choices there, you would be doing the problem incorrect. You have to start at your restrictions, especially when reps are not allowed. How many choices do I have for that first restriction? I have 2 choices. I'm going to go ahead and put an A there. I could have put a B there, but I'm going to put an A there and cross it off the list. How many choices do I have for this restriction right here? I got to do my restrictions first. Well, this has to be a B if there's an A there, so there's only one choice. I have to put a B there. I'll cross that off the list. Okay, now I've covered my restrictions. I'm going to go to this one. Now, actually, I can go to that one first, but I'm going to go to this one. I always like to go from left to right. How many choices do I have for this second slot, given this situation? Well, 1, 2, 3, 4, 5, 6, 7, 8. So let's go ahead and put a D there. Now, how many choices do I have for this third slot? 1, 2, 3, 4, 5, 6, 7. Put a 7 there, and then, you know, we can pick any letter. It doesn't really matter. I'll put a C there. Okay, I'll cross it out. I don't need to cross it out. So that's what I'm going to do to get my answer. I'm going to go 8 times 7, which is 56, and then times 2. So I'm doing all this without a calculator. 12, carry the 1, 5 times 2 is 10, plus 1 is 11. So 112 is the answer. Now, some of you may want to skip forward in the video because you're happy with this. I'm going to go ahead and do this the second method that I showed you on problem 7. The second method says this. I'm going to count all the ones that have an A there and a B there. So we can have words like that. Or we can have words where the B is first and the A is last. So A and B are the letters at the ends. And of course, these are restrictions. And I'm going to treat this as 2 problems now. Under each restriction, so let's just look at the first problem. We'll cover that one up. We'll look at the first problem. There's 1 choice there and 1 choice there. Now, having used up 2 of your choices, you only have 8 for that one and 7 for that one. And then we can just look at this problem on its own. These are the restrictions. B has to go there, 1. A has to go there, 1. I've used up 2 of my 10 choices, so I only have 8 choices here, so I can put like a D there, and then I would only have 7 there. Now, when you look at this, you end up getting 8 times 7, which is 56. The OR is a plus. 56, which is the same as 56 times 2, 112. So there it is. Now, I have a southern facing window and it's foggy out there, but the sun's breaking through the fog. So once it gets so bright that there's shadows and I can't see anymore, I'm going to have to pause the video and adjust it so the sun's not shining right on there. But yeah, this is kind of nice, I think. Hopefully it's not ruining the video. Okay, problem number 9. Maybe you can do this one on your own. If not, I mean, it's a tougher problem. How many different words containing the letter A can be formed if repetitions are not allowed? So now, your word has to contain the letter A. So how am I going to do that? Let's put up 4 slots. Contains the letter A. Where's the restriction? Well, that's the tough part. The restriction can be, the A can be anywhere, but it has to contain the letter A. So this is what I'm going to do. I'm going to say the A can go there. Watch this. Or A can go here, or the A can go in the third slot. Notice I wasn't planning correctly, so now the slots are getting a little shorter. Or the A can go in the fourth slot. So yeah, that's poor planning. Look at this. It's all smushed over there. So that's what I'm going to do. I'm going to break this problem up into 4 problems. And that is a way of doing this problem. I'm not saying it's the only way. So the restriction is there when we're doing this first problem. In fact, let's look at this. Suppose the problem just said the A has to be in the first slot. How would I do this problem? I would say, well, there is one choice there, and A has to go there. After putting an A there, I only have how many choices? Because repetitions are not allowed. I only have 9 choices. So I have 9 to select from. I'll put an I there. Cross that off the list. And then I have, you can count them, 8 choices for the third slot. I'll put an E there. And we'll cross the E off the list. And then, how many choices do I have for this slot? I have 7. Okay, so I'll put a 7 here. And I'll put whatever C there, I don't know. Now, from problem number 2, we already did 9 times 8 times 7, which is 504 times 1, so this is 504. So this counts all the words, repetitions are not allowed, where A is in the first slot. Well, now I'm going to go ahead and concentrate on this one here. All the words where A is in the second slot. Now I've already crossed things out, so I'm going to go do this a little faster. Well, if A has to be there, that's my restriction. There's only one way of doing that. I've used up a letter, so I only have 9 letters for this one. And now when I've used up 2 letters, an A and maybe a B, then I only have 8 choices there. And 7 choices there. So 9 times 1 times 8 times 7 is 504. Okay, the next problem. So there's 4 problems in one, but as you are seeing, maybe you're going, wow, these are very similar. Look at this. I do my restriction first. There's has to be an A in the third slot, so 1 there. And then after using up that A, I only have 9 choices there, then 8 choices there, then 7 choices there, which gives me a 504. And then, I mean, this is like one of those bad dreams, and it's the recurring bad dream. Okay, here we go. Let's do this again. There's only 1 choice. The restriction is in the last slot. There's 1 choice. You have to put an A there. And then after using up an A, this is a 9, an 8, a 7. So this is 504 as well. So I'm going to go 504 plus 504 plus 504 plus 504. Now you can do that, or maybe you realize that you can go 504 times 4. And when you do that, you get 16, 20, so you get 2016 for your answer. So that is one way of doing this problem. We are pretty much done with 6.2. I'm actually going to do this challenge problem, which looks the same. So some of you are like, I'm doing the bare minimum, so I'm going to shut off the video, and that's what you're going to do. And others will say, well, I want to see how to do this problem. How many different words containing the letter A can be formed if repetitions are allowed? So here it was repetitions are not allowed. And so you might go, well, shouldn't we be able to do this? Well, it has a star for a reason. Okay, so I adjusted the curtain. It's a little darker, but it's not going to cast a whole bunch of shadows. How many different words containing the letter A can be formed if repetitions are allowed? So how am I going to do this? Well, we could try doing this the way we did the other problem. We can count so this star means don't worry about a problem this complicated. We can count all the words that have the letter A right here. Or we can count all the words that have an A right there. Now there's a problem. When you count these words here, and then you count these words here, there's some overlap. And you might think, well, what is the overlap? The overlap would be like words that would have A's in both of those positions. Like our favorite one. So A is counted there, and it's also counted in there. So that's what makes this problem more of a star problem, because that's pretty difficult. But this is what we can do. We can be a little clever and say, let's make that a restriction and say that this one is not A. So A is counted in the first one, but it is not counted in the second one. Okay, let's continue. Or, I had to go put that right there, so that's why I'm kind of stepping down a little. We can count all the words where A is the third one, and we have to actually be a little bit more specific. Count all the words where your first A is in the third slot, which means the first one and the second one, they cannot be A's. So this would be not A, which is a restriction, and not A. And finally, we can count all the four-letter words, because this must contain the letter A, where the first occurrence of A is in the last slot. And then these guys are all restrictions. Why are they all restrictions? Because those three have to be not A's or non-A's. So not A, not A, not A. So there's four different problems here. The ors are going to become pluses, and we're going to see if we can get the correct answer. So repetitions are allowed. If you have to put an A there, there's one choice. Reps are allowed, so you can have 10 underneath all the slots that are not in red. So 1 times 10 times 10 times 10, that's 1,000. Plus, okay, this one, not A, is a restriction. And how many non-A's do you have? You have 9 non-A's, if I can say it correctly. And then you have an A there, that's one choice. And then 10 there, and 10 there, which gives you 900. Or, that's a plus, You have a non-A there and a non-A there, so that's 9 times 9. Repetitions are allowed, and then you have to have an A there, so that's one choice there, and then anything can go there, so there's 10. So 9 times 9 is 81. 81 times 10 is 810 or 810. Plus, not A, not A, not A, and then an A there. So not A is 9, 9, 9, 1. Let's see, 9 times 9 is 81. Times 9 is 729. So I'm going to add these all together. Ah! Okay. So you love it when your math teacher messes up. And then 729. So 9 there, and a 3 there. We have 15 plus 9 is 24. Carry the 2. So 2, 3. So my final answer for this is 3,439. Okay. Well, here's the deal. One time, I was teaching this class, and a student came up to me and said, I got the answer to this extra credit-like problem a lot more simply than what you did. And I said, well, what did you do? And the student said, I counted all the words. All words that you can have, which would be 10 times 10 times, we did this earlier, 10 times 10, okay? So that was the way the student said it. He said, I went 10 to the 4th, and then what the student did is they said, I went ahead and then calculated all the things that we don't want. So the things we don't want to have the 4-letter words without A's. So he counted all the 4-letter words that just had B through J. Well, if you're just picking B through J, there's 9 choices for each of the slots. So the student said, I went 10 to the 4th, minus 9 to the 4th. They didn't do this thing with the slots, but they probably did that in their heads, and they said, that is what I got. 10 to the 4th minus 9 to the 4th, I figured that out, and that was 3,439. And lo and behold, it is. So this just goes to show you that students taking this class, and I mean, a lot of you guys are probably pretty good at certain things, and sometimes you can find other ways of getting the same answers. And so this is very clever. It's almost like taking everything and subtracting the part that you don't want. We'll be doing this kind of thinking when we hit probability, and you end up getting the answer that you want. Now, having said that, and this might confuse some people, but I'm just going to say it anyway. If you go back to number 9 and you do that, you say I'm going to count all the words where repetitions are not allowed, and then subtract off all the words where repetitions are not allowed that do not contain A, that just have B through J. You will absolutely get this. Now, it's not going to be 10 to the 4th minus 9 to the 4th. It's going to be something different. And I'm not saying you have to go back and do this problem differently. And I'm not going to do that because I think one time I did that in class. People were completely confused with 9 after that. So number 10 was, kind of a challenge problem. Method 2 really is pretty slick, isn't it? Method 1 is, a lot of people like method 1 as well. And you get the same answer either way. So counting can get pretty complicated. I mean, this is not like a super complicated problem. It's simply stated. But this is the deal with counting and something called combinatorics, is sometimes the problems are easily stated and the answers can be a lot more complicated. But when you figure out the solution, especially if you're this student or someone who figures it out another way, it's a pretty good thing. You feel good about yourself. Let's go ahead and do the puzzle here. The whole key to this puzzle is saying these words out loud. So you might pause the video and say these words out loud and say, what does that remind me of? So I'm going to do that right now. Gun, shoe, tree, door, hive, sticks, heaven, gate. So, wow. What would come next? What does it sound like? Sounds like numbers. 1, 2, 3, 4, 5, 6, 7, 8. It rhymes with the numbers. So anything that rhymes with 9, like vine, or wine, or line. See, that's what we have here. 3, 4, 5, 6, 7, 8, 9. Well, that concludes this section. A little bit more complicated than the last one. So section 6.2 is done in terms of lecture. Do your homework. Have a good day. I'll see you in the next video.